And here we go. Calculators ready. So St. Joseph Wind Farm is a wind energy power plant in southern Manitoba. A wind turbine has a diameter of 55 meters, so you know it's a circular item. On average, it completes a full rotation in 80 seconds. So that is our period, right? That's how long it's going to take. Xavier observes how one of the blade tips reaches a maximum height at 120 meters after 5 seconds of the starting time. So that is important. They give us a little hint that right now this picture that we're going to paint will start at the max, okay? And that's 5 seconds after it started, after this action started. So technically 0 would be our starting time. But right now in this picture we're going to paint, it's at 5 seconds at a max where we're going to continue the picture and we're going to find 5 points that follow. So here we go. Determine the equation that models the height of the plane of the tip over time. On the exam, this is probably going to say determine the sinusoidal equation. They'll give it away, right? So if you read determine the quadratic equation, and you're like, wait a minute, but this kind of is a circular situation here. You go by what they say, okay? Don't argue, don't go linear or whatever, cubic. Go by what they say. Obviously, we're in sinusoidal right now in that chapter, so that's what we're assuming this equation is going to be. So A. So I encourage you to draw your box, right? And then we're going to split it up into 4 equal spaces. So I kind of overdid it. That's fine. And this is just for you to be able to gather your information. This is kind of like part of the work, right? So we have a high, mid, low, and then we've got our 5 lines, 4 sections split up. So what do we know? Because they give me the diameter, we know that this is 55. Okay, that we know for sure. From the top to the bottom is 55. And what I will do is I will go 55 divided by 2, split that in half, and so that is your amplitude, that's the radius. So we know that it's 27.5 and 27.5, right? So the diameter tells us also what the distance between the mid to the bottom or to the top is going to be. Coincidentally, this question tells us that the maximum is 120, right? The maximum is 120. So I'm going to use a red pen for that because I know this is fixed. Now that I have a fixed position, I can use the amplitude to get me to here, amplitude to get me to there. So I'm just going to grab my calculator. I'm going to go 120 minus 27.5. That's 92.5. Another minus 27.5, that's 65. And obviously you should see that 65 plus 55 gets you to 120, right? So you should see a pattern, okay? Then now I need my X scale. I know that I start at a max, and the time at that point is 5 seconds. So the dot will be at the top when X is equal to 5. That is given to by the question, right? The starting point. Now you need to figure out how much am I going to go up by. And so I will say that my X scale is going to be 80 divided by 4. So it's 20 seconds at a time that this increases. So that means that obviously from here to here it's going to be 80 seconds, right, for a full period. So 5 plus 80, we're expecting this to be 85 when we're done here. But what about in between, right? We're going to go up by 20 seconds at a time. So this would be 25, 45, 65, and 85. Okay, this is how much we're increasing every time we're going plus 20. plus 20. Okay, so there's a fixed distance between lines going sideways. There's always a fixed distance going up between the three lines, okay? So we have our sinusoidal going like this. Whoever designed this question, which is me, it's probably not a good idea to have 265 show up. So you got to change your numbers, right? If you were to write an exam question, maybe that's not a good idea because students may mix that up. Or they might find, wait a minute, what's going on here? Did I do something wrong? But we know that we're on the right track here, okay? Okay, so this is basically, believe it or not, this is part of your work, okay? You still need to come up with the equation. And the province tends to like a table where you fill in the numbers. So at 5 seconds, you are at 120. At 25 seconds, you're at 92.5. At 45 seconds, you are at 65. 65 seconds, you're at 92.5. And after 85 seconds, you're back to the top, right? So this is what you would kind of gather. And you put this into L1 and L2. You do a sinusoidal regression, so say that, and then you go y equals. When you do that regression, you get 27.5 sine of 0.08x plus 117 plus 92.5. Okay? So I'll tell you, the province is going to do this, okay? Because every teacher and some students might tackle this differently. The province will basically say, if one of these numbers is off, right? You do your regression, and if one of these numbers is off, it's -1 right away. Okay, you get 1 out of 2 if only one of them is off. If 2 or more are off, then you don't get anything. So chances are, if all you get wrong is get the period off, like let's say you started at time 0, but you have everything else correctly, like your period is 80 and all of that, only one number will be off, which will be this one right here. This number right here is what determines whether or not you're starting at the right time. So if you're starting at 5 and you're going up by 20, C is going to be correct, okay? So if you get your amplitude right and you get your midline right and you actually make sure this is an 80-second period, then all the numbers will be correct except for one, okay? So there's your equation, so that's A. I told you not to do the rest, correct? The graphing. I will do the graphing here because I think it's important to do that. So if you don't have room on this page, go to the back side. Okay. I already graphed this on my calculator, but before you do that, I would go to my window. Make sure X min is somewhat negative. And then the X max is 3. I usually do 3 periods. So I go 3 times 80, which is 240. And then just for good measure, I bump it up a little bit. I mean, whatever. It will work regardless. And then my Y min, I just go a little bit into the negatives. Maybe I go -5. And my Y max, I know that the max is 120 in this example, so maybe you want to go 130. Okay, and then hit graph. Okay. Oh, I don't know why I had that horizontal. Disregard that horizontal. That's what I'm seeing right there. Okay. Let's keep going. Let's graph this real quick. So I know if you have the graph on your screen, This is a windmill, right? So it's off the ground, and so it makes sense that it's up here, right? So the height of one of the blade tips is off the ground, and that's where it's happening, right? So let's graph our situation here. So I'm going to go y-axis and x-axis. I don't have to worry about the negatives. And I'm going to call this time in seconds. And I'm going to call this height in meters. So go ahead and do this because it's important to know how to graph this with or without a grid provided. What does it say? It says graph this for 2 full rotations. 2 full rotations. So I'm going to go, I need to have at least, if a period is 80, 2 times 80 is what, 160? I'm going to go to 200 just to be safe. So I'm going to go 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. That is going to be the safest. And if you need to label every single one, you go for it. You don't have to label every single one, but if that means you can find your points a little easier, then make sure you label the bottom, right? And then the Y, I'm going between 65 and 92.5. So I'm going to try this. If I go 20, 40, 60, 80, 100, 120, that actually works out perfectly if I do that. So I go up by 20s, just make sure you're consistent. I'm going to actually graph my boundary lines, like the top here is at 120. So I'm just going to make a dashed line to help me out. And I'm also going to have one at 65. This is 70, that is 65 right there. So I'm staying between those 2 lines. And again, for graphing purposes, I start at 5, right? I'm going to be at a high at 5. So I look at my scale. This is 10. So 5 would be right about there. So I just go up and just put a dot right there. 5, 120. And you do have a middle, so why don't we do the midline? 92, this is 90. And so 92 is right about there. I will do my midline because I do have those coordinates. Just for reference, right? So at 25, I'm at 92.5, so this is 25 right here. At 45, this is 50, 45 is right there. I'm at a low. At 65, I'm back to the mid. At 85, which is right about here, I'm back to the top. That's one cycle. How are we going to proceed from here? How much are we going up by every time we go from high to mid to low? We're going up by 20 seconds along the x-axis, right? That's one way of doing it. Or you just add 80 to everything. So this is 5. You add 80 to it is 85. If you add 80 to 85, you get to 165. So I'm right about here. So I just do my max there. If I go to this low and I add 80 to 45, I'm at 125. And that's good enough. So basically here, right, this is 80. This is 80. So once you have your top and bottom, sure, why don't you just use the period to figure it out? And make sure you, if you don't know what the y-intercept is, just go arrowhead here and then go like this. If this thing starts at the y-intercept, if it starts at time 0, obviously you're going to start right against the y-axis. But that would be 2 full cycles right there. No matter what you do, guys, make sure you're consistent, it looks symmetric, all of that stuff, right? And then you're good to go. And remember, close enough is good enough. However, they like to give round numbers or somewhat of round numbers. Like they don't often give you some weird decimals. So it is much easier to find the exact spot. So if you have an exact coordinate, we expect it to be exactly where you say it is. Yeah, all right? But if it's a decimal and it's a little off, that's fine. Okay. B, we've graphed this. C, let's do question C here. If you have space on this page, let's do it here. Part C, how long does the blade tip stay at a height of at least 90 within one cycle? Then we have to do Y2 is 90, second trace 5, right? So basically what they're asking is if this is your graph, focus in on just one cycle. How do you know one cycle? I would go from a low to a low or a high to a high, but I usually, I picture this situation. So your 90 is right here. Remember the top is 120, right? So 90 is somewhere here. So you're wondering how long does it take from here to here? That is the time you were at a height of at least 90. So we'll find both of these times. I didn't do that yet, so hold on. There's a brand new question just for you. Second trace 5. And remember, it doesn't matter on which cycle you fixate on, you just pick one. So I'm going to go enter, enter, enter. This one is this one here is 63.8409. And this one is a 106.1591. Okay. You do a delta t, you subtract those, 106.15 something minus 63.84 something. You get your difference of time. Make sure you don't round too soon. And that is 42.32 seconds. That's when you round at the very end. That's how long it stays at or above 90. And if you're wondering, should I mark this? No, you can just copy it because I think I just said the equation is what I'm after. If that's what you remember, that's what I'm pretty sure that's what I said. If you did all of this, that's great, but remember right now I'm getting you ready for the exam, so I'm not too concerned now with, I just want you to have tried this, okay? What is the range? A sinusoidal always has a limited range, guys. It's always restricted on both the top and the bottom, okay? So the restriction here would be as low as 65 and as high as 120. Or you could do range, use the squiggly brackets. You can use set notation as well, but that's what the range is. Copy this to the back, to the front. Wherever you have room, make that appear. E. What is E asking? If another turbine is built that is 10 meters taller but has the same diameter, how would the equation change? E. So I don't know if you remember, but if this, which one of the four, A, B, C, or D, affects, like, if you were to change it, would like shift this up or down? D. Yeah. Yeah. D is the letter, so it's that last one. So I would say increase. In this case, it's very specific. Increase D by 10. Okay, that's what you would want to do here. Let me zoom into that. So just, I'm going to copy paste everything else. And I'm going to go plus, that would be what, 102.5? Like I would want, we would have to see that you've increased whatever your D value was, you increased it by 10. It was 92.5, and now it's 102.5. Last question. If if the wind speed increases, how would the equation in A change? Give a specific example. What would happen to this graph if it spun faster? Would you spread this out, or would you bring it closer together? It would come closer together. Like it would actually, instead of doing this, it would do this, right? Because it's spinning faster now, it's actually going to compress this, and you're going to see more waves in the same amount of time, guys. Okay? You're going to see more waves in the same amount of time because it's spinning faster. Right? So I think it makes sense, right? If you look at a fan for a minute, it's spinning slow, you're like, okay, it takes 80 seconds to spin once, right? And if you were to speed that up, you would see probably it's spinning 2 times in 80 seconds, right? Same stretch. So which letter is affected by, which one would be affected if the wind speed increases? A, B, C, or D? Which one is, yeah, some of you I can lip read. Are you saying B? Yeah, okay. B is the one that would be affected. So I'm going to just, it says give a specific example, so I'm going to do that right here. This affects B. Do I need to increase or decrease B? You actually have to increase. Okay. And if you want to see it, you go to Y and just play around with the B there. If you increase that, let's say, what's bigger than 0.07? I would say 0.17. And if you graph it now, you see more waves, okay? Not a whole lot more, but if you went to 5.7, let's say, see? Oh, I have to do this one. If you change this to 6.7, right, even more. So if you're not sure, play around with your graph. I think, let me try something here. I think you can say, if you want to ever copy an equation down, I think you can say y2 is equal to, let's try this, y1. Are you going to have two graphs the same? Let's see. Oh yeah, the red one is right over top. Okay. That doesn't really help us a whole lot in this case, so never mind. I thought I was going to copy this over, but it just makes the same equation again. Anyways, that is this AC. I hope this helped. Let's stop.